Welcome to STEMMY Conversations. My name is Kenita, and here we have with us today Bradley and Stephanie. Before we get into it, I'd like to encourage you to follow STEMMY.conversations on Facebook, Instagram, YouTube, TikTok, and Anchor, where we talk all things STEM and ICT. Today, we have a lovely guest, Ms Teressa Alexander. She is a plant scientist with research focused on the cacao bean. She is a STEAM advocate and a SciComm by film and photography individual. Welcome, Ms Alexander, to our STEMMY Conversations podcast. How are you doing today?
I'm doing well. Thank you for the introduction. I'm doing well.
Welcome. Stephanie, how are you doing today?
I am doing great, actually. It's a new day. It's, well, another day to learn something new. So, yes, great.
And Bradley? Bradley.
Sorry, I was on mute. I'm good.
Okay, so let's get today started with Ms. Teressa telling us a little bit about herself and the career that she is in right now.
Okay, so I am Teressa Alexander. You can find me as Teressa Melko on social media. Melko is actually my middle name. And I just thought that my name was long, so I just shortened it by putting Melka in the end. So I'm better known that way. And I think sometimes I'm a bit of a multi-type interest type person. Yeah. So I do science, but I'm very much so interested in art. I really like the idea of film and photography and using that to communicate science. And so I'm in plant science. I had to correct in the beginning. You said cacao bean, so it's cacao tree, right? So I do my research is on the cacao tree. People know it as the cocoa. They say cocoa tree. This is what you use to produce chocolate and other cocoa products, and skincare and confectionery stuff like that. So I focus more on plant physiology. I think sometimes people think when you do plant work, you do botany, but I'm not, I wouldn't call myself a botanist. I'm sort of under the umbrella of botany, and that's plant physiology. And so I more so apply physics principles to understanding the mechanics of what happens in plants.
Okay, so thank you. Can you tell us how STEM or ICT is integrated into being a plant scientist?
So I think just even the acronym STEM, I mean, without the T, there's no STEM, right? So technology is very necessary in every aspect of STEM. You need to have some level of understanding computer science. You don't need to have a broad understanding, but I think of science as this very interdisciplinary place where you need to know a little bit about everything, especially if you do scientific research. So with me being in plants, I use ICT to do a lot of modeling, even with just creating graphical representations of my data. I need to have some understanding of how to do, why am I blanking right now? The word is blanking. I need to know how to code. Sorry, yeah, I need to know how to code. I was trying to find a way, but you need to know how to code, and that's the way you actually come up with these, your plots and stuff like that from the data you collect. I'll use instruments that are very much so technologically equipped. When I go into the field and I do field research, I do equipment and also to record my data, I need to have some level of technology.
Okay, thank you for that information. So I have one question, right? On your Instagram bio, it says you apply physics principles to the plants. How do you do that?
Okay,
Because for me,
so
in high school, I just know velocity and pressure and those. I don't know how it applies. So can you tell the audience how it applies to physics to plant science?
sure. So I actually did not start off in plants. My background is in physics. But just like what you said, you learn a lot about like velocity and all these different weird equations and all that stuff, but you don't know how to actually apply it to real world issues, right? So I started to get into research because of that. I was kind of frustrated, like why do I do differential equations? Where could I actually use this in something? And so I was directed to research, but I didn't start off doing plant science. So I started off actually doing a physics project, and I was bored because I didn't like it. But then I found that it could be applied to biological systems. And so I got into cancer biology research. And we were doing some project on sort of like figuring out how drugs bind to cancer cells. And it was sort of like drug design. But if there's the physics aspect of that was this thing called using a diffractometer to understand the structure of these molecules and to see how they bind to different how should I say different molecules, like how they bind to the cancer cell and in a 3D form, and that was the physics of that. But then I moved on to and this is within the area of biophysics. But then I moved into mechanics, which is something I really enjoy more within the realm of physics. And I started to look at how animals move. And there's a lot of physics in movement of humans, animals, marine animals, insects. And what this person was doing in specific was learning from the physics of their locomotion and then creating robotic models of these same animals. And so I got into biomechanics, but there's also plant biomechanics, right? And I think we think of plants, when you think of plants, you don't think of this very cool, interesting thing. And when I was introduced to plants and they said that they incorporate physics with plants, I too was very confused as how do you even incorporate physics into plants? There's a lot of mechanics that happens within the plant, within the regular day-to-day biological process. And one of those things is xylem function. One of those things is how, which is important for flow through the plant. And I'm not sure if you're familiar with the term fluid mechanics, but fluid mechanics is very much the physics. And also there is these, how should I say, like, I don't want to go into too many terms because then it would kind of get fuzzy. But basically, if I stay basic, the xylem is what helps water flow through the plants. And so the fluid mechanics of that is basically what I look at. That's really it. And what I measure.
Okay, I'm glad you were able to see how connected different different subject areas are, for the want of a better word. Bradley, you were going to say something?
No, I was going to say thank you for answering the question because it actually gave me an understanding of exactly how physics can be applied to real life. But real life application of physics because, like I said, it's just high school and they tell you about velocity and pressure and these things, and you don't know much of that.
Right.
So thank you.
Right.
Yes, and I would like to thank you as well because it gave me a better appreciation for the subject area of physics. I would have just read a few chapters from a book and it's like, okay, how would you apply this? And you actually gave me a different view as to how it could be applied. So that is pretty cool. And I would like to ask, what advice would you give to a young girl or boy out there that would venture out into the field of physics?
I would say to get into the field of physics. I mean, it depends on my decision to be in physics was solely because I thought that my career as a aviator wouldn't pan out, right? And aviation has a lot to do with physics. I mean, that's how planes fly, right? So again, that's an applied area of physics. So I went into to pure physics because I really wanted to be able to branch out into different things. And I felt like if I stuck with aviation, I would only be stuck there. But I think, you know, the world we live in today, especially with scientific research, you can be a biologist, you could be a physicist, you could be a chemist, you could branch off into so many different areas in your career. So it was all about me finding my path. And I chose something that was very broad, which is physics, to be able to branch off into different areas later on when I figured out my path. And so I think when people start a degree like physics, which is very challenging, you may get dismayed or you may get very discouraged. But I think one thing that kept me going was research. What kept me going was applying it to something in real life, what we could use it for in real life. I think, you know, when you get to something like, you know, in my senior year, when I got to classes like quantum physics or classes like advanced mechanics, and to, you know, calculate or to figure out one equation took 4 pages, right? You can lose. You can be very discouraged when you want to finish this degree. But I think when you see how amazing and how useful it is in things that we create today, in technology, in robotics, or what else? My love for
Engineering.
you know, my love for engineering, my love for planes, you know, design, things like that. You know, when you see that and how it's applied, like, I mean, yeah, I would say go for it. Don't get discouraged by how challenging it can be. There's a world of amazing things you can do with a degree in physics. You could branch off into so many different areas. And funny enough, if you decide afterwards you don't even want to be in science, you can go into business, right? I mean, you can go into law because people need scientists to be in those areas. And one of the examples of being in law is like a patent agent. People who have to look over scientific creations by someone, and you have to have a physics background or a science background to be able to look over effectively. And in business, you know, people creating these, even with medical devices, people creating different devices and whatever. Like, you know, it's applicable in business. So yeah.
Yes. So I think one important point for our viewers in terms of advice is it is okay to start on a broad topic. And as you go through life and as you do more, you get to figure out what is it that you really like to do. And that thing might be actually unconventional, you know, maybe something very different from what you would have expected yourself to get into. So it's okay to start big and then as you go through life, you know, narrow down to what you really like. So what were some of the requirements? I know that you didn't really have a straight path, but okay, what were some of those things that you would have done to help you get there? So what are some of the requirements to be a plant scientist? Maybe we could start very basic because our viewers are, you know, very entry level. So maybe you would have done a degree, probably did some courses.
So in secondary school, I did physics. That was the only science I actually took. And that was the only one I was interested in. I wasn't so much interested in chemistry and biology at the time. So it's funny how I'm in the realm of biology.
Yeah.
But so I would say start from, because even in secondary school doing physics, that was very helpful when I went to college. It's not advanced physics, but at least it's like a fundamentals you learn about that will be helpful when you're moving forward and doing a physics degree. When I got to college, you sort of have to do it all over again in a way. But as you say, for instance, when you get into college, you sort of focus more on specific parts of physics. So that's what I learned throughout the path. So I think it's important to have the fundamentals, you learn a broad idea of it. But then when you get to college, and when we kind of glazed over optics, no, you have to do a subject in optics, and you glaze over mechanics as this broad thing, you're specifically doing certain things in mechanics, right? There's different types of mechanics. And like I mentioned, fluid mechanics, and then there's analytical mechanics, and yeah, it goes on. But another thing I would say is to have a strong math foundation. Math and physics go hand in hand. There's a lot of math in physics. Now, if you don't like math, I don't know, but you need to have a strong foundation in math. I wouldn't say you have to be the best at math, because I wasn't the best, but I would say
be consistent.
definitely practice and have patience. And I wasn't making a joke when I said, you get to a higher level of physics, and I think even a high level in math, when you are trying to calculate one equation, and it could really take 4 pages without writing out this equation. That's not a lie, it's the truth. So, especially in college, you have electives that you have to choose. You could choose, for me, I could choose something in engineering. I chose to do fluid mechanics. That's another very challenging thing. But I would say the most important thing is to have a strong foundation in math, patience, don't get discouraged, and seek out the fundamentals. So if you are in secondary school, definitely do physics. For CSEC, I'm not sure. For CSEC, do it. A levels, if you CAPE if you can. When you get off to college, you have to do it all over again, and then it's not going to be the same way. It's going to be calculus-based physics, which is even more. But yeah.
Thank you. Bradley or Stephanie, you have any other questions or so you might have for Ms Alexander?
The advice you gave is actually very, what should I say, encouraging. In high school, I did physics. I wanted a career in physics. I didn't know what I wanted at the time. But for some reason, my maths, I'm not good at math. And that's where the problem lies. You have to have a strong foundation in maths, or you would, it would make you feel like, to quit. So it's either you work on your math skills and then do physics, or something of the sort. Because for me, I can tell you, when I did physics, my math skills sucked. And I used to cry my neck, like, I want to give up. But my mom used to say, man, give it another shot. So our advice is literally true. Oh, one other question, Teresa. You mentioned you did physics in class. As a plant scientist, what is it exactly you do in terms of research? What is it that you look for? Is it that you just inspect plants? What do you check for directly?
So my project is on the climate change. And so there are so many different types of cacao. And of course, they have different morphological and physiological behaviors. And I look at how the different genotypes behave under drought conditions. And the big picture of that is to develop a drought tolerant tree because of what we're seeing in climate models coming up for the Southern Caribbean area, which will bring drier conditions. And so we're thinking, let's shift a little bit of the focus into creating or developing something that's more drought tolerant to withstand these climate changes, which will bring drier conditions. There's a lot of focus on disease resistance, but not so much in drought tolerance. And so when you think about plant breeding, you want to think about breeding something with drought tolerance too. Yeah.
Okay, thank you. Stephanie, have any other questions for Teressa?
No, but some of the key points she mentioned earlier when it comes to going into the studies, you need to have the patience. That is something very key. And also the perseverance as well. So you gotta find what motivates you. So I think that's a key takeaway for me. Because as you said before, you might feel demotivated as soon as you see one equation call for 4 papers. It's like, okay, this is a whole different ball game, but you got to remember why is it you're doing this and push forward. So yeah.
One thing I would say too is if you can find a mentor, somebody within, you may not know, like I didn't know what my career would be when I first started college. I thought, in secondary school, I wanted to fly planes and do all this great stuff, but I still do, I still want to fly, I just can't afford it. But I think for me, it was important for me to seek out folks who were sort of within the career already. And, I worked at the airport and I would literally see like a pilot come and I would start having conversations with them and they would give me their contact information and I would learn more about aviation. I would learn more about like what is required. When I was in college, I got into science and I started thinking about internships, and internships are extremely important because those are other things that you are able to get practical experience with what you're learning, and that excites you even more. So internships, finding a mentor, somebody within that career or realm of career, or they could be any kind of scientist, I guess, just ask questions and they will give you great feedback. I would go to conferences and I would meet folks doing interesting research and I would spark up a conversation. They'll give me their contact information. I'll learn more about it. And I may not like it anymore, or I may like it. And then I could have the opportunity to get an experience in it. Some of the internships that I got, I didn't even apply to. It was because I went to a conference, met someone, had a great conversation with them. They gave me their contact information. I spent 4 days with them in their state learning about their work, met their PIs or their advisors. We had great conversation. And then one summer I emailed, well, before the summer, I emailed and said, hey, I'm interested in what you do. And they will send back something and say, well, do you want to come work for us in the summer? I never applied. So, it was kind of like networking,
Yeah,
so that's
networking.
Networking is very important.
Mm-hmm.
And that was one of the major things for me, getting the opportunities that I got to have to do practical experiences using physics. So yeah. Networking, mentorship, and look for internships if you can. But from secondary school level, may not, be accessible. It can be, because I do know when I was in the States, I do know students who were able to actually have some level of experience in a lab when they were in high school, but which I think should happen in this region. But yeah, mentorship, internship.
I feel like one of the two most important things that screamed at me was mentorship and networking. I don't have a mentor. I should try and find one. I don't know how to like start finding one. And networking. I see networking as a skill because I am the type of person to speak to people, yes, but the networking, the following up, the having a really great conversation is something I need to work on. So those are the two things that screamed at me just now. But thank you, Ms. Alexander, for speaking to us today. We really enjoyed the conversation, and I hope that our audience understood the advice that you would have given, and that they would understand that, you know, finding a career path is not always straight. It's not always okay, I'm gonna do this and then do this and then do this. But you know, along the way you might see other things that you like and you might actually just get into that. So I'm happy that our audience was able to get an insight into this career of a plant scientist and basically how you went about getting there. So thank you for tuning in to STEMMY Conversations. Stephanie, Bradley, and Ms. Alexander, do have a great rest of your day.
You
You
too.
too. You too. Thank you for having me.
You too. Thank you for being here, Teresa.
Thank you.